Plus, you already have been using the other huge table too.
Hi, my name is Kelsey and I'm an undergraduate student here at the Math Lab. I just completed my undergraduate thesis here in the lab where I studied the eye patterns of undergraduate students as they solved simple addition problems in digit and word format. What I wanted to study was the difference in cognitive processing between problems presented as digits and problems presented as words. So what I did was I got students to come in and solve problems presented on a computer screen while an eye tracker tracked their eyes to see where they were looking at the problems. So the different types of problems that people would see were simple addition problems. The smallest one was 2 plus 2 and the biggest one was 9 plus 9. These would range from small to large problems, a small problem being something like 2 plus 2, and a big problem being something like 6 plus 9. The problems presented in the screen were broken up into 3 different interest areas, a left, a center, and a right, for the left operand, the addition sign, and the right operand. Now, we tried to look at 2 different variables. One was the amount of times that they looked at each of these different areas, and also the length of time that they looked at these different interest areas. This is an example of a digit problem because there are digit numbers here in the interest areas. This is an example of a word problem because there are word numbers presented in the 2 interest areas. Along with people solving the math problems, after every trial we got them to report what type of strategy they used while they were solving the problem. This could be retrieval, counting, transformation, or other. The results for total fixation time were different for digit and word, which is what we were hoping to find. So for digit problems, the total fixation time was focused on the center interest area, or in other words, the plus sign. For the word problems, it was different because people were fixating not on the center interest area, but on the left and the right interest areas, especially for large problems, as you can see by the solid line there. For the percentage of retrieval, it was found that digit problems took more retrieval than word problems overall. Also, small problems used more retrieval overall than large problems, as seen in the dark bars compared to the light bars. Overall, we found a difference between digit and word problems, which means that there are different cognitive processes used when people solve problems presented as digits and problems presented as words. This information helps to find out the differences in cognitive processing when people are doing mathematics, and it can even help to develop different tools and aids for people who struggle with math.